Hi and welcome to this video on power regression equations and exponential regression equations. A shout out to Don Dawson who requested this one. He wanted to check what the difference between them are, and it's a very good question. So I'm going to extend it a bit. The video, my apologies, will probably go for a bit longer than the last couple. So power regression equations, the general form can be modelled by this. You've seen these plenty of times. So 3x squared power regression equation. X cubed, 4x to the 5, even 10 on x. All of these are power regression equations in that we have our variable here as the base, and up here the indice will change. The power actually changes. So these things are power equations, and we can actually determine a regression of these. We're given a set of data. So that's what we'll do now. Here's the set of data, and we've been told that the data listed in the table above is thought to be modelled by a quadratic model. So we know quadratics are power equations, so we're going to perform a regression analysis on it in order to determine an appropriate model. And then we're going to use that model to find our unknowns. Okay, you'll only find these, or typically find these in the calculator active parts of your exam. So we're going to go into that. The first thing we need to do is go into the stat button. We're going to enter our data. So number one for edit. If you've got data in there and it's not the data we want, you can actually just navigate up. So you see them at the top of that list, and we're going to clear that list. Okay, and I'm going to repeat the process over here and again clear that list. So once we've got that in, I'm going to put my data in. Now, just as I enter the data, note that I use the negative rather than the -3. And I'll put the data in, but where there's data which is incomplete, for instance -1, we've got an unknown there, I'm going to skip that. I'm only going to enter the data where I've got full data pairs for, so skipping -1 onto 0, then to 1, 2, 3, and this b value clearly won't go in either. Going over to 2, or this 2, I'll then put in the corresponding values, again skipping the a. And you've probably seen already, or you can determine what we might expect in terms of a power equation that might describe the relationship between x and y. But we'll have a look and see what's going on and if the calculator can actually do it too. So now the data's in, go to stat. You're going across to the calc menu, and remembering that you have been told quite explicitly, and this is typical, you'll be told what the model is presumed to be. You can actually say, okay, it's a quadratic model, so what I'm going to do is I'm going to go down and perform a quadratic regression on it. So again, don't be worried about having to guess which model is it going to be, because most questions, certainly in an exam context, will actually tell you what the assumed equation will best fit the model. If you're in a problem-solving modelling task where you've got a lot more time to actually go about experimenting and finding which one fits and analysing R-squared values, different story again. But for these, we're just testing. We will give you a clue as to what it is. In fact, a very direct clue. So we've been told quadratic regression. I'll hit that one. This one's in there. If you needed to change your list, just use the second and the numeric keys to select your lists. Obviously, this one's the one we want. This 2 as well. And if you want to store the regression equation, go to vars, go to yvars, select 1 and select 1 again. And it'll actually select y1, which will pop up in here later on. We'll have a look. We'll go and calculate that. And you can see my regression equations given there, and it's given in the form of quadratic. So we can respond to this question by saying using, let's move that up, using GC and what was it, the quadratic regression function. We have found that y equals, now generally it's ax squared plus bx plus c. A is given the value 1, so it will just be 1x squared plus no lots of b, so it would be 0x plus c. Now this value of c, you might recall, that is almost close, well, very, very close to 0. We're actually looking at 1.5 by 10 to the -14 there. That's the way we should be writing that in scientific notation, but our calculator does that. In context, that's 14 zeros, the leading one, and 13 others before we get to the 1 and the 5. So you can see in terms of a decimal, it's tiny. This is close enough to y equals x squared. So having determined that, we can then say, let's find a. So a is our value up here. So y equals -1 squared. So we want to find that value of a when x equals -1. So of course -1 squared will just be 1. So a equals 1. Looking and finding b, perhaps I should have actually labelled that a, but find b, and here using again that equation y equals x squared, let's just write it down. We've been told that the y value is 25, so x squared will be one of those things, so we'll have to take the square root of it, won't we? So that'll be the square root of 25, which could equal positive or -5. Okay, in the context of this, I would suggest that we could almost reject the -5 because we're on an, well, actually no, we couldn't, because looking back over here, if we went back to -4 and -5 back here, we would expect 25 to pop up. So we've got two possible solutions for that. Okay, so that's the power regression. Again, the x is the base, and we have a variety of powers and occasionally a coefficient in front of it. So, pressing on. Exponential regression. Here's our general formula. This is the way the calculator writes it. Okay, but we might see it in general day-to-day use as 2 to the power x, or 3 times e to the power x, or even this one, which you've seen in a variety of forms there, where population equals the initial population by e to the power x. So here you note that we have the x value is our exponential, it's our indice. Okay, so it's actually popping up here compared to a power function when it was actually down as the base. Now, similar to last time, we have some values here, and we're told that it's believed that the data shown in this table can be modeled by an exponential function. So again, we give you a fairly direct indication about what sort of regression that we want you to perform. Not that we say you need to perform a regression, but we do ask you to determine a model for this function. So the regression methodology is a good one. So just going back into here, we'll go back to our stat, enter option 1, edit our data. Now you see the data on the top line is very much the same, although I might have to make some changes there. So let's just go and re-enter it again. Oops, what's happened there? I'll skip 2. Remembering that unless you've got the full data pair, you just don't put it in. Oops. And it is a good idea just to go back and check that your data matches. Yes, all of those match. I haven't made any errors. Of course, if you make errors with your data input, you're going to struggle. So, going back now to our stat menu, we will navigate across to our calc, and remembering that we've been told that it is an exponential function that we're anticipating. We go to exponential regression, select it, and again go through the process of our list. Now list 1 and 2 as described, we want to store that regression equation. So there we go under vars, y vars, select option 1 and option 1 again, and it pops in, and we'll get that to calculate. So there it's actually calculated it for us, and we'll say using graphics calculator an exponential regression function, y equals, and you can see here A's got the value of about 1.01. Remember, 2 decimal places in your exam's fine. Times B, where B is 1.99 to the power x. Okay, so just putting that in the form A times B to the power x, where A and B take those values. We want to find A. So A in this case is when x equals 2. So A, or writing the equation down might be a good first start. And substituting for x is 2. So therefore A equals, now let's go back here, and if I go y equals there, you'll see there's my regression equation in there. Now we can plot it if we wish. Let's do that. And you notice that in here, because I've actually got stat plot on, I've got all those points in there, and you can see the regression equation passing through those, or very close to them. Now if I go to second calc, I could just put this into my calculator if I want, but the other thing I can do is if I press option 1, my value, and just put 2 in, 2 being the value of x, it will actually determine that for me as 3.9966. And of course, we only need that to 2 decimal places in our exam, so that's a value of 4. Does that work? Well, yeah, that looks about an eighth, a quarter, a half, 1, 2, 4, the one we just calculated, 8, and this one which is as yet unknown. So let's find B. So here, again, our equation is a good starting point. So B is our y value, that equals 64. Whoops. Let's do a bit of backtracking. I'll divide both sides by that 1.01. So quitting from there. So 63.37 equals 1.99 px. And then I'm going to go, let's take the log function. So we'll put this in the log form where we've got log of 63.37 to the base of 1.99. I'm going into the calculator, going to math, going to our log base option. That 1.99 goes into our base, and the 63.37 can go in there, and therefore x is approximately equal to 6.03, again to 2 decimal places, and that would be our value for B. So using the graphics calculator, it's very easy to actually enter your data, select the appropriate regression type if you're trying to find an equation, and again it will be stipulated in the exam, in the question itself, what type it is. So choose the appropriate one, and having done so, then move on and find the equation and solve for any unknowns you've been given. My apologies for the length of this video, but I do hope it's helped.